Hello everyone. Today we are going to discuss what is data structure, classification of data structure, and different types of data structure. So basically, what is data structure? So it contains data structure is a way to store data. Obviously, it deals with data management. So it is a group of data elements, and what we will do in data structure is that we're going to store data in an organized way so that whenever it is needed we can retrieve the data and we can use the data efficiently. So that is the definition for data structure. And then comes the classification of data structure, where basically it is divided into two types: primitive data structure and non-primitive data structure. Where in primitive data structure it contains all the basic data types like int, char, float and all. And in non-primitive data structure it is again classified into two types: linear data structure and non-linear data structure. So if it is a linear data structure, the data will be arranged in a sequential or linear order so that it can be accessed only one by one. Whereas if it is non-linear, data are stored in an hierarchical order. So the examples for linear data structure are arrays, linked list, stack, queue, and for non-linear, trees and graphs are examples for non-linear. So moving on to the linear data structures, arrays. So these arrays you would have learned in C programming itself. So basically it is a collection of data elements of same type. Contiguous memory will be allocated for an array, and to access the element we will be using the index. So for example, I have an integer array A of size 5. So 10, 20, 15, 5 and 8 are my elements, and using the index 0, 1, 2, 3, 4 I'll be accessing the respective elements. Linked list. So linked list is an alternate method for array. The major drawback in array is it needs contiguous memory allocation, and the memory will not be used efficiently in an array. The array size will be declared in prior, and we may not be using all the allocated memory in an array. So to overcome this drawback in linked list, dynamically we can allocate memory. So elements are stored in node, where the node format is shown here. So where we have a data part and a pointer part. The data part will contain the actual data, and the pointer part will point to the next node that contains the next element. So this is an example of linked list. So this is an example of linked list where we have three elements in a list: 10, 15 and 30, and each and every element are stored in a separate node, and each and every node will be stored in available memory, and the pointer is used to connect these elements. So 10, the first element is available in a node that is available at the memory 100, and the second element 15 is available in the second node which is allocated with a memory that starts from 200, and third element 30 is available in a node that is allocated in the memory 1000. The pointer part, using this pointer part, the first element gets connected to the second element, and the second element gets connected to the third element. And obviously we should know the address of the first node so that it is possible for us to access the remaining elements. So using this head pointer, we can access the first element. Once we get the first element, using the pointer part, we can access the memory location of the second element. So this is how a linked list will be there. And insertions and deletions can take place at any point in a linked list. Either we can insert an element at the beginning or at the end, or else in the middle. Similarly, deletion can also take place at beginning, end, or at the middle. The third type of linear data structure is stack, where insertions and deletions will take place only at one end, top of the stack. So this is the structure of a stack. So where we have only one end called the top, and insertion and deletion will take place only at using that one end, and that end is called as the top. So the first one shows the insertion of first element 10, second element 20, third element 30, and when we try to delete an element, the topmost element will be removed. So when we try to remove the element, only the topmost element can be removed. So 30 will be removed. And so next deletion 20 will be removed, and the next deletion 10 will be removed. So it has insertions and deletions can take place only at 1n. So that is your stack data structure. Moving on to the next linear data structure is queue. So we can relate this queue to a normal queue where we have a reservation counter or ticket counter where we will follow a queue, right? So the same methodology is applicable here. So insertion takes place at one end and deletion takes place at the opposite end. So this is the structure of a queue where we have two ends, front end and rear end, where in rear end insertion will take place and in the front end deletion will take place. So this is queue data structure. And moving on to non-linear data structure. So we have two important non-linear data structure, tree and graph. So if it is non-linear, elements are arranged in hierarchical order, non-sequential order, non-linear order. So I have given the structure of a tree here. So basically it follows a parent-child relationship, and the topmost node is called as the root node. So only with the help of this root node it is possible for us to access the remaining elements. So when first thing I can access in the tree is the root, and from this root I can access its children. So this becomes the parent and this becomes the children. So 2 becomes the parent for its children 4, 5. So it generally follows a parent-child relationship. So this is the root node, and the nodes that doesn't contain children are called as leaf nodes. So the elements are stored in a hierarchical order. So when the accessing is not in a sequential order, so from 1 either I can go to 2 or 3, and when I go to 3 I can go to either 6 or 7. So it is a non-linear order, that is the thing. And the next type of non-linear data structure is a graph. So it is a generalization of tree structure, and one real-time example for graph is we are nowadays using Google Maps. So Google Map is the best example for a graph. So graph contains vertices or nodes and edges that connect the vertices. So this is an example diagram for a graph where we have 5 vertices or nodes A, B, C, D and E, and we have edges connecting all these things. So when I want to travel from A to E, I can either choose the path A, C, E or A, B, D, E or A, D, E. So based on some criteria, we will be following the path and we can move from one node to the other node, from the source node to the destination node.